Hello student, welcome to my solving tech channel. Myself Narayan Sharma. Today I like to discuss with you about integer. So let's start. First I write the name integer. Integers. Okay. So before going through integers, we let some recap about the number system. As you know, integer is one of the part of our number system. So first, in our number system, first it is come natural number. Natural number. Natural number. As you know, 1, 2, 3, etc., etc., all the counting numbers are collectively known as natural number. So natural numbers start from 1, 1, 2, 3, 4, dot, etc. are natural number. So smallest natural number is 1 and the greatest one we don't know because it is natural numbers are uncountable. Next it is whole number. Whole numbers. Whole numbers, 0 and all natural numbers are collectively known as whole number. So in whole number you take 0 and take all the natural numbers, that is 1, 2, 3, 4, 5, dot, etc. are whole numbers. So now let's go integers. Let us draw a number line. You know the number line? So this is a number line. Number line. At the middle we have 0. That means at the middle it is occupied by 0. And from 0 almost equal distance. You take some points in the line, almost equal distance. These are points in the right side. And in left side also, almost equal distance, you give some points. Take some points. Okay. Now, in right side, the numbers, the whole numbers are occupied. 1, 2, 3, 4, 5, etc. In the left side of 0, the negative numbers of the whole number. Negative numbers of the whole number means in right side it is 1, in the same distance in left side it is minus 1. Then from 0 in right side it is 2, same distance in left side it is minus 2. Then it is 3, then here it is minus 3. Then minus 4, then minus 5. So in this number line, all are integers. All these are integers. So here 0 is called 0 integer. 0 integer. And 1, 2, 3, etc. these are known as positive integer. Integers. And minus 1, minus 2, etc. these are known as negative integers. Okay. Now, so how can we define integers? We can define, or the definition of integer can be cited as 0, all positive That means 0, all the positive numbers, positive, all the natural numbers and their negatives are collectively known as integers. I repeat the line, 0, all the natural numbers, these are natural numbers, all the natural numbers and their negatives are collectively known as integers. So how can I write a definition here? Definition 0, 0, comma, all natural numbers, all natural numbers and their negatives are collectively known as integers. So this is the definition. 0, all natural numbers and their negatives are collectively known as integers. So the whole set of integers can be symbolized with the capital letter Z. Or you can write like this: integers can be represented with the capital letter Z. Capital letter Z. Z means integers. Okay. So we can write integers. So integers are 0, 1, -1, 2, -2, 3, -3, etc. So these are the integers. Okay. Now I have the board. In the number line, whenever you go, you get from right side to left side, you get a smaller integer, and similarly from right side to left side, whenever you go from left side to right side, you get gradually bigger integer. I again draw the number line. Middle it is 0, 1, 2, 3, then -1, -2, -3. Whenever you go from right side to left side, gradually you get the smaller one, and whenever you go from left side to right side, it is bigger one. You get the bigger numbers. That means you see -3 is less than -2. Similarly, -3 is less than -1. -3 is less than 0. Okay, then -3 less than 1. Then -3 less than 2. -3 less than 4. -3 less than 3, etc. Similarly, in case of -2 less than -1, -2 less than 0, -2 less than 1, -2 less than 2. Similarly, -1 less than 0, -1 less than 1, etc. Now, some situation we can represent with the help of integer. What kind of a situation? Suppose gaining rupees 50. Gaining rupees 50, you can write as plus 50. Gaining rupees 50, that is plus 50. Then whenever you losing rupees 50, that is minus 50. Gain positive interest. Whatever gain, here I take rupees 50. Suppose gaining rupees 100, that is plus 100. Rupees 1000. Gaining rupees 1000, that is plus 1000. Okay. Similarly, deposit a amount, say deposit rupees 100, that is plus 100. Deposit plus 100. Withdraw rupees 1000. Withdraw rupees 1000, that is minus 1000. In this way we can represent this situation with the help of integers. Suppose this is our direction line. Here it is north, then it is south, east, west. Suppose if we movement toward the east, if we take positive, then movement toward the west is negative. Similarly, if we movement toward north is positive, then movement toward south is negative. That means, say, movement of east 5 step. Movement toward is 5 step. Movement towards east 5 steps. You may write plus 5. Then similarly, movement towards west 5 step, then it becomes minus 5. In this way we can with the help of integer we can cite this type of steps. Okay, now we said about the property of integers. That means how integers are closed in different properties. As you know, that different properties are, first one, it is closure property. First one, it is closure properties. So in closure property we say closure property, that means closure property in addition. We have closure property in addition. In closure property of addition we say sum of two integers is also an integer. Sum of two integers is also an integer. Sum of two integers, that is, you see minus 2 plus minus 5. So minus 2 plus minus 5 we get minus 7. And minus 7 is also an integer. Similarly, 10 plus minus 8. 10 plus minus 8 is 2. So 2 is an integer. Similarly, minus 15 plus 10. Minus 15 plus 10 is minus 5. So minus 5 is also an integer. That means integers are closed under the closure property in addition. So this is the closure property of addition. In closure property in addition we get sum of two integers is also an integer. And here is the some examples. Next property is commutative. Commutative property. commutative property. The commutative property, you see, suppose A and B are two integers. A and B are two integers. That means if A plus B is equal to B plus A plus B equal to B plus A. This means sum of two integers is remain same if their addends are altered. A and B are the two integers. When A plus B, you get a result. Similarly, B plus A, both the results are same. So take some examples. Example, 4 plus minus 5. 4 plus minus 5, you get minus 1. Then minus 5 plus 4, here also minus 1. That means 4 plus minus 5 equal to minus 5 plus 4. Similarly, so this is example 1, example 2, minus 9 plus minus 12. Minus 9 plus minus 12, it is minus 21. And minus 12 plus minus 9, that is also minus 21. It means minus 9 plus minus 12 equal to minus 12 plus minus 9. So we can say integers are closed under commutative property in addition. The next property it is associativity. Associative. Associative. Associative property. Associative property in addition. Here also, let A, B and C are integers. Then you see A plus B plus C. You take B plus C bracket. Next one, A plus B plus C. This time here A plus B bracket. So this is the associative property. A plus B plus C whole equal to A plus B whole plus C. Now take some integer in place of ABC. 4 plus 7 plus 8 equal 4 plus 7 plus 8, that is 4 plus 7 plus 8. So here your result you see 4 plus 7 plus 8, 50, and then it becomes 19. Here you see 4 plus 7, that is 11, plus 8, that is 19. If you take some minus sign, minus negative integers, minus 8 plus minus 4 plus 6, then equal to minus 8 plus minus 4 plus 6. Take here result, minus 8 plus minus 4 plus 6, you get 2, then it is minus 6. Here you see minus 8 minus 4, it is minus 12 plus 6, minus 12 plus 6, that is minus 6. So this means integers are closed under associative property in addition. Integers are closed under associative property in addition. Similarly, integers are closed in distributive property are not, we check it. Distributive property. distributive property in addition. So here also let A, B and C are integers, then under distributive property we get A into B plus C, that is A into B plus A into C. So this is the distributive property under addition. Another distributive property, A into B minus C equal A into B minus A into C. So now in place of ABC we take some integers and let us check whether the integers are closed in distributive property or not. Let us check. Say in place of A we take 2 into, in place of B we take minus 8 and C it is 6. That is minus 2 into minus 8 plus 6. And what we get? Minus 2 into minus 8, then this plus sign, again minus 2 into 6. So finding the result, minus 2, minus 8 plus 6, that is minus 2, and here it is plus 4. And in right side what you get? Minus 2 into minus 8 plus 16, and here it is first you take plus sign, minus 3 is minus 12, and plus 16 and minus 12 it is get 4. 4 equal. So from this conclusion we get that integers are closed under distributive property in addition. So we get that integers are closed under closure property in addition. Integers are closed under commutative property in addition. Integers are closed under associative property in addition, and integers are closed under distributive property in addition. So you can say whether the integers are closed in associative property in subtraction or not, commutative property in subtraction or not, and closure property in subtraction or not. Similarly, integers are closed under closure property in division or not, associative property in division or not. In this way you can say. Okay. Next one property is additive identity. Additive identity. Every integer you have a additive identity. That means if A is an integer, then its additive identity is is minus A. If A is an integer, then additive identity of A is minus A, because A plus minus A equal to 0. Whenever you add the integers and its additive identity, you always get 0. So example, additive identity of 7 is minus 7, because 7 plus minus 7 equal to 0. So I make a sort of additive identity of some integers. I write here integers, and here it is additive identity. Then dt. Okay. So any example I take, that is minus 10. Additive identity of minus 10 is 10. Why? It is because minus 10 plus 10, minus 10 plus 10 equal to 0. Similarly, additive identity of minus 12 is 12. Additive identity of 1 is minus 1. And additive identity of 0 is, you have to write 0 because 0 is neither positive nor negative. Similarly, additive identity of minus 1 is plus 1. So in this way you can find the additive identity of integers. Always remember, whenever the integer is minus, our additive identity is plus. That means additive identity of negative integer is positive integer. Integer remains same, just only its sign is altered. When it is plus, then it becomes minus. And again you have to check whether the sum of the integers and the additive identity is 0 or not. You have to check. If it is 0, then yes, your additive identity is correct. In the next one you see minus 12 plus 12. Whenever you integer is minus 12, then its additive identity is plus 12. It is because minus 12 plus 12 is 0. Then 1 is minus 1, 0 is 0. 0 is 0 because 0 is neither positive nor negative. So if you write here minus 0, then nothing to write here minus 0. Minus 0 is also a 0. So that means the additive identity of 0 is 0. Then minus 1, additive identity of minus 1 is 1. Next, multiplicative identity. In place of additive identity, I write multiplicative identity. Multiplicative identity of integers. So multiplicative identity of integer, let a be an integer. Let a be an integer, then multiplicative identity of a, multiplicative identity of a is 1 by a. It is because whenever you multiply a and 1 by a, your result is 1. So learn this line. If a be an integer, then its multiplicative identity is 1 by a. Reason, a into 1 by a equal to 1. That means the product of an integer and its multiplicative identity is always 1. Product of an integer and its multiplicative identity is always 1. So take some examples. Multiplicative identity of 10. Multiplicative identity of 10 is 1 by, here I take minus 10. The multiplicative identity of 10 is 1 by minus 10. It is because minus 10 into 1 by minus 10, you get 1. Minus 10 into 1 by minus 10, it is 1. So here I make an chart of multiplicative identity of some integers. And multiplicative identity. Okay. So integers, let 7, multiplicative identity of 7 is 1 by 7. Yes, 1 by 7. Then minus 2, multiplicative identity of minus 2 is 1 by minus 2. Similarly, multiplicative of 1 is 1. Multiplicative identity of 1 is 1. It is because 1 by 1 is equal to 1. Similarly, multiplicative of identity minus 1 is also minus 1. It is because 1 by minus 1 equal to minus 1. Similarly, 0 has no multiplicative identity. 0 has no multiplicative identity. It is because suppose 0, then it becomes 1 by 0. So 1 by 0 is not defined. This is why 0 has no multiplicative identity. So lastly, you have to get it. 0 has no multiplicative identity. Okay. So in this way, we can set the additive identity or multiplicative identity of integers. So students, I like to finish today's class here. In my next video, I will elaborately go through the integers. Please keep watching my channel, that is Solving Tech. Thank you for watching.